Welcome to helpyourmath.com. In this video we're going to be talking about the slope of the line graph, right? So what is the slope of the line graph for each of these graphs we see? And each of these graphs are particularly made with different x and y coordinates so that we could work out the functionality of all of them. Besides this, we also have the slope equation on the bottom left here, which says the slope, the m value, equals y2 minus y1 over x2 minus x1. Also, we want to remember that the slope is the change of y over the change of x, which indicates the rise over the run. And this is really important, and I won't get into it until we get to the last two of these components, because it's important to understand how your slope of an equation is working when you're figuring out the slope of a line. Now, for the first two, what we're going to do is we're going to use the general form of the slope equation and the interpretation of how to do this correctly. For the first one, I'm not going to really focus on any details because realistically, it doesn't matter which coordinate you plug in as x1, y1 and x2, y2. But it is important when you're doing it from left to right to figure out how that works. And so for the first coordinate set, we're just going to work right off of whatever we want. And for the second coordinate set, we're going to do it with greater detail. All right? And so what we're going to do first for part A here is determine the coordinates of these intercepts. And since they're intercepts, we know the x-intercept occurs when y is equivalent to 0. And the x value is the intercepting coordinate point of this equation. And if you look at our graphs here, we don't have any markers for any other x and y values. The reason for this is specific. We just want to focus on where the intercepts occur. Using those coordinates of where the intercepts occur makes this a lot easier for you, and it makes the work a lot easier to transition through. And so here we have our slope of negative 5, 0 going through 0 and 4, which is the y-intercept, and our x-intercept. And so for part A here, we're going to use our general form of the equation of the slope, and our two coordinate points are negative 5, 0, or in this case, let's just put 0, 4 first, and negative 5, 0 second. The reason why I'm doing this is specific, because it doesn't matter which order your points are made when you're using the slope equation. And this is a really technical point because when you're doing the slope using any of the 2 points, it still gives you the same value, regardless if you're putting them in the correct order, the way that it should be. And arbitrarily, the work comes out consistent because you're using the formula of the slope equation. And so here what we want to do is make this our x1 and y1, and this our x2 and y2. And so what we're going to do is then use the equation of the slope to calculate our value. So m equals y2 minus y1 over x2 minus x1. And here we're going to use parentheses to parenthesis in each value. In this case, my y2 value is 0, so I'm putting 0 in parentheses and subtracting my y1, which is positive 4 in parentheses, over my x2, which is negative 5 in parentheses, minus my x1, which is 0. And in this case, these usually work very easily because you're using zeros as the corresponding pair for your intercepts. And so when we're subtracting with 0, it's really easy because 0 take away 4 is just negative 4. And negative 5 take away 0 is just negative 5. And so here the resulting slope becomes the quotient of negative 4 over negative 5, which is actually just positive 4 over 5. So our first slope is a positive slope. And we can tell this is positive, especially if you looked at our previous video for slopes, that when we have a coordinate set going from left to right in an upward manner, we get a positive slope. For our second problem here, we see our coordinates are going downward. And the correct way to do this if you're doing points from left to right is to take your points as x1, y1 to x2, y2 from left to right. And so here we have our point 0 and 4. And our second point here is 3 and 0. And so we're going to make this one our first point because our first coordinate as we're going from left to right is 0 and 4. Our second coordinate is 3 and 0. And so we're going to use 0, 4 as our first coordinate and 3 and 0 as our second coordinate. So here we have x1, y1, x2, y2. And so our m equals, again, the slope equation. And what happens when you're doing this is your denominator will always be positive. So if you're running your equations for coordinates from left to right, from the first of the 2 points to the second of the 2 points, your denominator would always be positive. In this case, we saw in the first problem, part A, our denominator was negative, and that's because we chose negative 5, 0 as our x2, y2, in which case this should have been x1, y1. And we're going to see the difference it makes here right now. So let's plug this in and see what happens. So my y2 is 0, and my y1 is positive 4. My x2 is 3, and my x1 is 0. And so here our result for the denominator is going to be a positive 3, while our numerator here is 0 take away 4, which is negative 4. And our slope is then negative 4 over 3. And so we see here that our slope is negative 4/3, and we see that in the graph of the equation as the graph is going downward, indicating that this is a negative slope. All right? Now, since we've used the formula to coincide our slope values of positive or negative based on the coordinate points or the graph if it's going up or down, we see that our positive and negative reflects based on the points. So here we could already estimate this is going to have a negative value and this is going to have a positive value. However, instead of just using the slope equation, we're going to use this change of y over the change of x. Since we already know the sign of these equations, we could just make our fractions based on the changes of y over the changes of x. All right? So for part C here, what we want to do is we want to calculate our change of y. Here's our point of origin. Here's our point of x. Here's our point of y. And so here, we know this is going to have a negative slope value already. So for part C, we know our resulting slope is negative. And what we want to have is actually a consistent value of the change of y over the change of x. And since here we're looking at our change of y, we see this goes from 0, 0 to this point of 0, negative 3. And so the change of y here becomes a positive 3 since it's moving 3 units downward. And here our change of x is going from 0, 0 to negative 6, 0, which shows that this has a value of 6 on this side of the triangle. And so since we already know that our change is going to be a negative change, we'll call this delta x a positive 6. And our slope is already negative because it's coming downward. Just like we saw here in part B, we had a negative slope because it's coming down. And so this is also a negative slope. And our change of y, which indicates our rise, we see that from the left point to the right point, the slope is going down 3 units. From 0, 0, from negative 6, 0 to negative 3 and 6. Negative 6 and negative 3. And so creating this triangle, which is the same triangle as the one we see up here, we see the change is going downward 3 units. And so the first numerator is going to be negative 3. In our denominator, our change from left to right is positive 6. Since the points always go from left to right increasing, this has a change of 6 units to the right. And this is where our 3 and our 6 come into critical play here, because we know this is going down, so we already applied the negative. All we had to do was indicate the change of the y, which is a 3, and that becomes negative 3, over the change of x, which is 6. And so here we have negative 3 over 6, which when we reduce this, becomes negative 1 over 2, indicating that our slope is negative 1/2. All right? And even though this may have been a little bit too quick for some of you to follow, we're going to use the second problem to do the same exact thing. This time what I'm going to do is I'm going to isolate and truncate this little triangle, replace it over here so that I can work out the functions of what's actually happening. And so here, what we're looking at is the triangle that goes through these points, where this is a 4, this is a 1, and this is a 0. And so here we could definitely just calculate the change of the x and the y. And so here we know this is the delta y, and here we know this is the delta x. Now our delta y indicates how many units there's a difference of here. And from 0 to 4, there are 4 units. And so this just becomes a 4. And here from 0 to 1, this is just 1 unit. Now we also know that our slope is positive because it's going up from left to right. So we could already determine that our slope is a positive slope. All we have to then determine is the change of the y over the change of the x. In this case, our change of y is 4, right? So we have change of y over change of x, and we have a positive 4 over 1. And 4 divided by 1 is just 4. And so here we could determine that the slope of this equation is just positive 4. Thank you.